The Tokenomics Foundation just defined tokens as the atomic unit of the AI economy: a cost unit, a cognition unit, a value unit, and a pricing unit. But there's a dimension missing. Every token produced requires compute. Every compute cycle requires electricity. Every kilowatt hour has a carbon intensity, and every GPU cluster requires water to cool. When Goldman Sachs projects 24x token growth by 2030, that's not just a cost curve. It's an energy curve, a water curve, and an emissions curve. Tokens are also an emissions unit. And that's what Flexera's AI Sustainability makes visible. This is our AI Sustainability dashboard, built on real usage data from our accounts and subscriptions. Here's the overview. 4 KPIs: carbon, electricity, water, and cost, tracked side by side. Not cost in one tool and sustainability in another, together. In just 3 months, our AI workloads produced about 13 metric tons of CO2, roughly 8 transatlantic flights, nearly 32,000 kilowatt hours of electricity, what 3 homes use in a year, and almost 168,000 liters of water. Total spend? Around $267,000. And notice, every one of these is climbing about 10% month over month. Without visibility, that curve just keeps going. With this visibility, we can bend it. Sustainable tokenomics starts with knowing where tokens go. Now let's break it down by model. 2 donuts, 1 massive insight. On the left, carbon by token type. Output tokens are 47% of carbon, but only 16% of cost. That's the hidden emissions iceberg. If you're optimizing on cost alone, you're missing where nearly half your carbon lives. On the right, spend by token type. Input tokens dominate the bill at 66%, but they're relatively more carbon efficient per dollar. Cost and carbon don't tell the same story. Sustainable tokenomics means watching both. And here's the headline. One model family, GPT 4.1, accounts for 75% of our entire consumption. That's not 100 small decisions. That's one big lever. This is where it gets actionable. The comparison tool puts any 2 models side by side on energy, water, carbon, and cost. GPT 4.1 uses 4 times the energy per 1,000 tokens that DeepSeek v3.1 does. And across the full chart, the most intensive models burn over 20 times more energy per token than the most efficient ones. Not every task needs the biggest model. When teams can see this trade-off, right-sizing stops being a guess and becomes a data-driven choice. And that is the heart of sustainable tokenomics. And finally, the raw data. Every meter, every token type, every deployment zone, with 5 columns: tokens, cost, carbon, electricity, and water. This is where you see that cached input tokens are less carbon intensive than output tokens. Region matters too. Data zone, global, and regional deployments carry different carbon profiles for the same model. This is the level of granularity the Tokenomics Foundation's working groups need to ensure efficient token consumption. The Tokenomics Foundation defined 3 pillars: token production, consumption, and monetization. AI Sustainability adds the sustainability dimension to all 3. Dashboards don't reduce emissions, operating models do. This is what that operating model looks like. Thanks for watching. Let's connect and walk your team through it live.